Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. And today we're solving a Bill Murphy puzzle. This is called Counting Different Sudoku. And we have normal Sudoku rules, so we're placing the digits 1 through 9, once each in each row, each column, and each outlined 3x3 region. And in addition to that, we have some clues with little arrows outside of the grid that point along a diagonal in the grid. And what is going on there? So the clues each indicate the number of unique, that is different from each other, digits that appear anywhere along that diagonal. So for instance, this 3 clue outside of here tells us that there are exactly 3 different digits on this entire diagonal that the arrow is pointing to. And now Bill has done us a favor. He's already given us 3 distinct digits appearing on that diagonal, so we know that the other positions on the diagonal can only ever be occupied by those digits, making this a 6 and making this a 5-7 pair. So we're going to look out for other 3 diagonals first. So 3, 6, and 8 here along this 3 diagonal. That tells us this has to be a 3. And these two have to be 6 and 8, and because we have a 6 there already, that'll be my 8 and that will be my 6. Now this 3 diagonal, we have 3, 4, and 5, so this can't be a 7 because that would be adding a 4th digit. So we have a 5 there, and then a 3 and a 4. And now along this diagonal we have 4, 6, and 9, so these also can only be from 4, 6, and 9. There can't be a 4 there because of the 4 already in row 6, so that's going to be a 4 and a 9. Let's see if we can do a little bit of Sudoku before we approach the 2 diagonals. So we have 6s here and a 6 here. That places a 6 right there. And we have 4s here and a 4 there, and that's going to place a 4. And we also have a 4 right there, so that's going to place a 4 right here. And I believe we can get this cell if I'm remembering correctly. Maybe we can't, or maybe I'm just being very foolish. We can only place a 5 there or there. We've got 4s. 3s can only go there or there. I know you guys are probably screaming right now, like, Clover, look at the screen, it's right there. But I will get there. I've got a little bit of the flu while I'm doing this solve, so unfortunately I might not be up to my usual standard for solving, but I'm doing my best to share this puzzle with you because it's a really good one. So we have a 2 clue along this diagonal. Let's look at some of the 2 diagonals. So we already have 2 digits here. We have 8 and 6. So these have to be the same. They have to be 8 and 6. This one can't be a 6, so that's my 8. And then that's going to be a 6. This one I don't know what my second digit is. Like, really all I know here is because these have to be distinct. They're in the same region. One of them is going to have to be a 4, and then the other one's going to be the other unique digit. So I can corner mark 4s there. Here I've got 5 and 3, that tells me this is a 3-5 pair, and here I also have 2 4s, and it tells me one of those is going to be a 4, but I don't know which one at this point in the puzzle. Alright, so that's a little bit of progress. Let's see if we can do anything interesting with that. So we do have 4 8s now that are all pointing into region 1 together. That tells us the only position for an 8 in region 1 is going to be right there. We do have these 5s and also this 5 pointing into this region, so 5 has to be in one of those cells. That's not quite as helpful, but that does give us something. Here we are going to need 1, 2, 7, and 9. That's not a 9, that's not a 1 or a 9, that's not a 2 or a 7. Here we're going to need 1, 2, 5, and 7. Those can't be 5s, that can't be 1 or 7. This is probably not exactly the right approach for this puzzle, and I did actually solve this one before I solved this in testing, apparently a little too long ago because I have clearly forgotten the entire solve path. Down here I'm going to need 1, 2, 3, and 8. That can't be a 1, that can't be a 2 or 8, that can't be a 2 or 8, so I do have a 1, 3 pair there, which gives me a 2, 8 pair. I'm not sure that's exactly relevant yet, but hopefully they'll give me something later. Oh, I have a 1 and 9 in this row, so that's going to be a 2. That makes this a 5 and resolves a little bit of stuff. That's no longer a 5, so that'll be my 5 in the central region. This is now going to be an 8 to finish off the row that it's in. And this can only be 1, 7, or 9 within its row, and I have 1 and 9 in the column already. So that's a 7, which resolves that into a 9 and removes the 1 from those try values. So now over here, what do I still need? I need a 3 and a 9, and they're going to have to go there and there. I have a 7, which resolves my 2 7 by value and cleans that up a little bit. Now this is going to be a 2. Those can't be 2s. I have a 3 up here, so that 1, 3 is resolved. I have a 9 here, so that's a 1, a 7, and a 9. And what do we get from here? We've got a 5, which lets us take care of this 3, 5 pair. And the 5 we just placed from that is going to give us a 5 over here. We now need to place a 3 in the bottom row. Can't go in those 2 cells. Can't go in the 7th column because of the 3 right there. So that's going to be our 3. And now we have 2 3s looking up into region 3, blocking off these cells. And then this 3 over here eliminates 3 from that cell. So that's going to be a 3, and then we'll place one more 3 right there. That's the only position possible for 3 there. The top row is nearly done, so let's have a look at that. We need 1, 2, and 7 to finish that row, and that is not going to resolve just yet, so we'll leave that be for the moment. Column 2 is looking nearly complete. We need 2, 4, 7, and 9. This can't be 7 or 9. That can't be 2 or 4. And I don't think I get much else there. These are going to be 6, 7, and 9 in the row. And that's going to make this a 9, which will resolve that into a 7. And we can eliminate 7 up here, which finishes the entire column. Fantastic. Now the only position for a 4 there, actually we've already placed our 4, so that's all good. So we have a 1 there, eliminating 1 from those cells. That makes this a 5, 7 pair, which resolves right away. Right here I've got a 4, and I need a 1 and a 2 to finish the region. I've eliminated 4 here now because I have a 4 in the row, so that's going to be a 4. Here I need a 6 and an 8 to finish off the row, and here I need a 1 and a 7 to finish off this row. Vertically here I have everything except for a 4, so that's going to be a 4. I've got a 9 right there. I have an 8 already in the column, which resolves that into a 1. Deals with my 1, 7 pair, my 1, 8 pair here. That can only be a 2, and that's a 7. And that is how you solve Bill Murphy's lovely count difference Sudoku. I hope you enjoyed that one. I certainly did, and if you want to solve it yourself, the link to do so is in the description below this video. And I'll see you again a couple days from now.